This assessment asks us to give the mechanism of the reaction of this ether to be cleaved by two equivalents of HBr to give the two alkyl halides shown. As we go through the mechanism, we'll think about which CO bond breaks first and explain that as we go through. Now the reaction is going to start with HBr being a really strong acid. It can protonate the ether oxygen. When that happens, we're going to end up with a molecule that has a positive charge on the oxygen. Now at this point, we can look at this in one of two ways. We can either talk about this group having a good leaving group attached, or we can talk about these carbons having a good leaving group attached. And so now we're ready to make that decision of which CO bond is going to break first. Well, if we look at this carbon, it's primary. So if this CO bond is going to break, if this group is going to leave, it's going to have to do that through an SN2 reaction. SN2 reactions require two molecules to come together. Hold that thought. If this CO bond breaks on the other side, we're going to be left with a tertiary carbocation. Notice we're not considering SN2 here because you can't do SN2 at tertiary. So our choices are two molecules coming together to do an SN2, or one molecule simply falling apart in an SN1 reaction. The SN1 reaction happens first. So the first CO bond that's going to break is going to be this one, because it's going to be easier, faster to just form a stable carbocation than it is to do that SN2 reaction. Not to say that the SN2 reaction can't happen, because we're going to see it happen in just a second. Once we've formed this carbocation, though, it gets attacked by bromide to give us this first product. Now, if we look at what the leaving group was in our SN1 reaction, it was this alcohol. If we look, we note that this alcohol now needs to become this alkyl halide. We're going to do that by simply reacting this alcohol in another acid-base reaction with HBr. That's going to generate an excellent leaving group in the case of water, right? We've got this water molecule kind of contained within this protonated alcohol. Now this carbon is still secondary, so water, still primary, so water can't just leave. Now is when we're going to do that SN2 reaction to directly displace water and give us the other alkyl halide. This is the mechanism of the acidic cleavage of ethers.